All right, happy Friday, everyone. This is our initial training on multivariate coherence training. We're going to go over some evidence of efficacy and what it can be utilized for. So, for those of you that are new to this technology, this is a schematic that explains what the four-channel multivariates training program and protocols look like and what they're based upon. They're always based upon four channels of EEG that are represented by sensors A, B, C, and D in this location. Each pair of combinations has a running calculation for coherence in the eager software that's represented as a p-sync value. In other models, it may be called coherence. You do want to make sure that whatever system you're using, that the coherence algorithm is equivalent to the one that we've utilized. For each channel, the three pairs of coherence values are computed and averaged. So for example, the coherence between A and B, A and C, and A and D are all calculated. They're averaged, and that value represents what we call shared variance at sensor location A. That's done for B, C, and D. So there are shared variance values over each location, and those four are then averaged for what we call a QPS average, which is our single metric that represents the multivariate coherence combinations across all four sensor locations. That is then utilized to reward or inhibit multivariate coherence during the actual training itself. We also utilize three inhibits, and they are power inhibits averaged over those four sensors as well. And those are based on QEEG excesses in, say, theta, alpha, beta, whatever it might be for that particular patient. Okay, so that's how a protocol is set up. In future trainings, we'll have more information about protocol setup and examples of how you actually do that. This is our seminal article where we initially published 3 years ago our evidence showing the effectiveness of the treatment. And basically, what we showed over about a sample of 170 patients of various diagnoses when we compared two-channel to four-channel coherence training, two-channel coherence training to four-channel multivariate coherence training. We showed on the left-hand side over here, as you can see, a doubling of the effect per session in power metrics. So the inhibits went down by twice as much with the four-channel training. And in the coherence values, almost a 400% treatment effect, where coherences would go in the direction they were trained, usually up, but in the direction they were trained of a magnitude of 400% greater than doing two-channel training. So it showed greater efficacy, at least in manipulating the variables we were looking at in the training itself. In eager, as it's created, there are three modes of the four-channel training. I may get into that in another training experience, what's called average, deviation, and QPS mod, where we look at different aspects of training this. And I think I will wait for another time to talk about that in specific. There are other softwares that have this algorithm built into it, but not necessarily these three modes. Please reference our website, which is integratebrainhealth.com, for papers, presentations, slideshows, webinars on all of these topics. You're welcome to peruse that at your leisure. In terms of anecdotal evidence of individuals, patients we've treated, we've done in our own clinics hundreds and hundreds of cases over the past 7 years with this technology, and we've consulted on many, many others. So we're talking, I have not counted the numbers, but thousands and thousands of patients that have been through this treatment, many of which in the early days of this that have been through other types of neurofeedback. But our anecdotal evidence of effectiveness includes individuals with OCD traits, seizure disorders, autism, TBI, dyslexia, speech language dysfunction, emotional regulation, depression, and developmental trauma, anxiety related disorders. Of course, individuals like ADHD improve, other learning disabilities, and there are other conditions, but these are some of the ones that we focused on. We published a study, what's called a meta-analysis study of all of the different studies we've done. So we've done separate studies on a general population study that we discussed earlier of 174 subjects. TBI, epilepsy, learning disabilities, autism, depression, developmental trauma, and autism with mirror neuron dysfunction, which is a specific category within the autistic spectrum. And we compared all of the experimental subjects in those groups. There were a total of 591 patients altogether to derive this meta-analysis. It's worth mentioning that in every study there was a positive effect where the 4-channel multivariate coherence training had a greater impact on clinical outcome than other types of neurofeedback or waitlist group or psychotherapy, whatever the comparison was at that time. If you guys ask, I'm happy to do separate trainings on some of these individual studies. Just let me know if that's an interest. When we pool all of the subjects, all of the experimental clinical subjects, it's a total N of 305. If you include the control samples, it's 591, just so you know the numbers that we're talking about. And this is the numerical breakdown in each study for the experimental groups. They were getting the 4-channel multivariate coherence training. So you can see that across studies. And here was the effects. Generally, an effect size of between 0.4 and 0.6 is considered a significant outcome in most social science research, just so you have that notion in mind. So a Cohen difference of 0.02 looks like this, 0.05, 0.08. So the larger it is, the bigger the separation between the groups you're comparing in terms of efficacy. That's the idea. So when we look at two things, we look at clinical efficacy, that is, does it change their presenting symptoms across all these samples? Our Cohen effect size was 1.8, which is 3 to 4 times the value of an expected moderate to extreme effect size. When we look at connectivity in general, the Cohen effect size is 2.8, which is hard to do the math on that one. But if you look at maybe 0.5, you're looking at 5 or 6 times the ratio of that, which means that there's a 99.7% chance that this is a real effect. In the clinical effects group, there's a 96.41% chance, way, way beyond statistical significance, showing that the efficacy of this treatment for these various conditions is very stable, both in terms of being able to alter connectivity in a therapeutic direction and being able to change their clinical symptoms to be less problematic in their lives. These are the effect sizes for each of the subject samples, and you'll notice that the largest ones include the ASD mirror neuron grouping, developmental trauma, learning disabilities, and our general population study that we did. So it's very interesting. LD, ASD, developmental trauma, anxiety disorder, PTSD, those seem to have the greatest impacts for whatever reason we don't know. But all of these are very significant. The general notion here is that was in terms of clinical effects. In terms of connectivity, There's no effect size that's lower than a 2, so they're all quite significant. The largest include the LD population, again, epilepsy, developmental trauma, and traumatic brain injury. So the basic notion here is that the greater the presumed connectivity disturbances in these populations, the more effectiveness, efficacy this treatment can have. So when we know that TBI, ASD, learning disabilities, developmental trauma all come, seizure disorders all come with significant connectivity anomalies, and those are the ones that are responding the best to treatment. So if you're ever wondering, what patients are best to look at this model with, they want to be ones where you expect there to be connectivity anomalies. And again, we can talk about who those patients might be, what populations, what symptom presentations. That would definitely be for a future presentation. So I'm going to leave it there for now. Hope you all get a chance to watch this video. And if you have comments or questions, please leave them in the Facebook or LinkedIn group that you're part of. I do plan further presentations. The next one probably would talk a little more detail about what the treatment looks like and what it is, and how you set up initial protocols. And then from there, we would go on and talk about the assessment, the QEEG and connectivity assessments we need to do to prepare for such a protocol. But again, if you have ideas, if you want me to talk more about the research in different populations or anything like that, I'm happy to insert some trainings along the way as well. So just let's just talk back and forth in the group. The discussions are great, and we just want to have more of that. That's why we have these groups. All right. Okay. Everyone have a happy Friday and a great weekend. Thank you.